Hey everyone, welcome back to my channel. Today we are deep diving into LangChain, which is one of the most powerful framework for building LLM applications. Using LangChain, we can build chatbots, questioning answering system, and AI agents. So if you're someone who is curious to know how those big models like ChatGPT we can use in our application, LangChain is the tool you need. So in this video, we're gonna cover out about the basic concepts of LangChain. We're gonna talk about what is LangChain, what are its components, what is a LangChain framework architecture, and many more things. And after that, we're gonna deep dive into the programmatical concepts that are involving LangChain. Using those concepts and components, we can use LangChain into our Python program and implement application. So let's get started without wasting any time. So let's get started with LangChain framework. So LangChain is a powerful Python framework. So it helps developer to develop application powered by large language models. It supports OpenAI, Hugging Force, Cloud or Mistral. But the main component of LangChain, why it is so popular these days, is because you can with LangChain you can work with text, tools, memory, and the data. All of the things are combined in a single ecosystem that promotes the LangChain to variable use cases that involves LLM. It helps you to develop production-ready LLM applications. Now let's talk about why we need LangChain. So LangChain is built with modularity and flexibility at its core. So it provides well-defined components. So each of those components represent different parts of your LLM application, like prompt, memory, chains, agent, tools, and output parsers. So what makes LangChain so powerful is that its ability to easily swap, customize, and extend these components. For example, in LangChain, we can switch from OpenAI to Hugging Face model with minimal changes. So that plugin feature offers us the accessibility and portability of changing the models at an ease. At the heart of LangChain, it lies the concept of chains. So these chains are nothing but the sequence where each step involves an LM call or a logical processing. So LangChain provides built-in support to define these chains, to customize the behavior of these chains, or maybe combine multiple steps into a single pipeline. We can create simple chains or complex ones like document processing followed by summarization and questioning answer on top of it. This abstraction, basically provides an ease to the developer to control the structure of their LLM workflows with clarity and precision. One of the biggest strength of LangChain is incredible development speed. The LangChain ships update very frequently and reliably, ensuring that we have access to latest LLM features like API updates, tool integrations. It also performs performance optimization at the backend so that we don't have to worry about while developing the code. LangChain also has active and welcoming community of developers and researchers. It also have regular meetups, hackathons, etc. So because of these features, this is makes using LangChain very easy and so much popular these days for developing LLM based applications. Now let's talk about LangChain framework architecture. The key components of LangChain includes LangChain core, LangChain, integration packages, and LangChain community. So let's get started with LangChain core. So at the heart of everything is LangChain core itself. We can think of it as a foundation. It defines the base abstractions, including the blueprint for the components like chat models, vector stores, tools, retrievers, and memory. It does not implement any of these components directly. Instead, it says here's what a tool or a model should look like and how it should behave. This allows developers to plug it in any other model or store as long as they follow the same structure. The next component of the LangChain is the LangChain package itself. It's a brain of your application. It is built on top of LangChain core and contains high-level chain, retrieval strategies, and agent logic. We'll see all of them in the coming videos. This is where your app's cognitive architecture takes shape, whether it's a document QA bot or it's a multi-step reasoning agent. The key is it's a integration agnostic. Like it does not care if you use OpenAI, Hugging Face, or any other provider. As long as you're following the same architecture, it works well with the application. The third component includes the integration packages. Now, to actually use a specific LLM or vector database, you need integration packages. These packages are like including OpenAI, Anthropic, Chroma Vector Store, and many more. Each package implements its own interfaces from the LangChain core to connect to real world API and tools. By keeping them separate, LangChain makes app modular lightweight. You only need to install what you need. It doesn't install everything all at once. You will only install OpenAI when you're using OpenAI models. You will install Chroma when you're using Chroma. Otherwise, you don't have to install anything, and it makes your app very light. The last component of LangChain framework is LangChain community. This is where you'll find all third-party integrations. They all are live, contributed, and maintained by the community. Need to connect to a lesser known vector store or a new LLM provider? You'll probably find it here. You can even contribute to this community. So by this, you can actually have the LangChain as a clean package and it is still contributing to the rapid growth. Now we'll see the main building blocks of LangChain, the main core component that help to build smart AI apps using language models. Prompt template. So this is the first building block of the LangChain component. The prompt template helps you to create a structured prompt. It's just like a fill in the blanks for your language model. We'll see the working of this using a Python program in the coming video. The next component is the LLM itself, which stands for large language model. So LangChain allow you to connect different LLMs like OpenAI, GPT-3, GPT-4, Hugging Face model, Anthropic Cloud, and many more. So all of these model you can connect with a 2 or 3 line code in Python supported by LangChain. The next component is LLM. LangChain supports different LLMs like OpenAI GPT-3, GPT-4, Hugging Face model, Anthropic Cloud, and many more. All of these models you can connect, and it is actually the brain of your application which is behind the answers. The third component of LangChain is chain itself. It links multiple steps together just like a pipeline. So each step might include an LLM call, running a function, or just passing a data to the next step. All of these steps can be clubbed together using LLM chains. The next component of LangChain is memory. Memory is what lets your app remember the past conversation. Without memory, every instruction is like a brand new chat. But with memory, the application can track of what was said earlier, just like a real assistant. So the example use cases include AI tutors where we have to track the progress. So if we remember the past conversation and the past chat with the student, then we can better guide the student for the future topics. In LangChain, we have various type of memories like conversation buffer memory, summary memory. We'll do a full demo video on memory in the another video. The next component is the agents. So agents are nothing but the smart decision makers. So instead of having a fixed flow, we can have agents decide what to do next based on the input. Like consider the example that what's the weather in Paris and convert to Fahrenheit. So and the agent can call a weather API or maybe use a calculator tool and then give the final answer. So agents are just nothing but like a router that select the best action based on the given input. The last LangChain component is tools. So tools are nothing but just like external function or APIs that agent can use. So LangChain support tools like search tools, maths calculator, API like weather, Wikipedia, etc. or your own Python defined functions. So basically agents think what tools to use. Tools actually do the task. LLM explain the results, all working together like a smart assistant. Now we have finished with all the LangChain components. In the next video, we're going to talk about how we can implement each of these components using the Python program. We'll see how we can create chains, call the LLM models, or may use memory to build the assistant. If you found this video helpful, please drop a like, drop your questions in the comments. Thanks for watching and see you in the next video.